Okay, the topics here is limits at infinity. So we need to look at the definition. The definition we're going to be using is square root of a over square root of b is equal to square root of a over b. And this is really important. If x is a positive number, how do we do square root of x to the fourth? Square root of x to the fourth is the same thing as square root of x squared. And using the absolute value definition, this is the same thing as absolute value of x squared, which is x squared. Now, same thing, if x is negative, square root of x4 is square root of x squared, which is absolute value, but this time we get the same. In other words, from both of these, we just got square root of x4 is equal x squared, no matter as x goes whether to negative or positive infinity. So this way, example 16, 17, 18, we're going to get the same thing, and you'll see why. So this is equal limit. So first, since this is x squared, we need to divide both by x squared, right? Because the denominator. But since there is a radical, instead of writing x squared, you write it down. We need to divide by x squared is square root of x4. So square root of x4, same thing for the top. We're going to divide by square root of x4. Now this is equal to limit of the top. We're going to write it as one radical. So x4 over x4 plus 1 over x4, and the denominator, since we don't have a radical, we're just going to write square root of x4. As x goes to infinity, we just realize it's just x squared. Now this is equal to limit as x approach infinity. Now this one goes to 1, this goes to 0. Well, we need to do maybe one more step. So square root 1 plus 1 over x4 over, if we divide the denominator, we'll get minus 3x squared over x squared plus 4 over x squared. Now we can simplify this. Let me do one more step. 1 plus 1 over x4. And this is minus 3 plus 4 over x squared as x approach infinity. Now this goes to 0, this goes to 0. So the answer will be square root of 1 over negative 3, which is negative 1 over 3. So therefore, we can say that y is equal to negative 1 over 3 is a horizontal asymptote. Well, they're not asking us that question, but this is the limit. But if the question was trying to know if there's a horizontal asymptote, then you're going to say this is a horizontal asymptote, right? But the question is only asking us to find the limit. Right? Now, same thing here. The question is just about the limit, so this is going to be, but it's going to be the same answer. Why? Because we're still going to divide by x squared. So minus 3x squared plus 4, divide both by x squared. Instead of dividing by x squared, since we have a radical, just like we did for the first one, we divide by square root of x4, which is the same thing. Square root of x4 as x approach negative infinity. Everything will be the same like example 17. So limit as x approach negative infinity. If we put everything under radical, we're going to have x4 over x4. By the way, we're using this definition, right? So plus 1 over x4, everything over minus 3x squared. As x approaches negative infinity, it's still x squared. So x squared plus 4 over x squared. Now this is going to be equal limit 1 plus 1 over x4 over minus 3 plus 4 over x squared. As x approaches negative infinity, we know this approaches 0 and this one approaches 0. So we get square root of 1 over negative 3, which is negative 1 over 3. So we can still say, even though the question is not asking us for horizontal asymptote, it just means that y equal negative 1 over 3 is a horizontal asymptote as x approaches negative infinity. Yeah, and that's it for these examples.